Psittacosaurus. Psittacosaurus/Cydicosaurus/Psittacosaurus, parrot lizard, is a genus of extinct ceratopsian dinosaur from the early Cretaceous of what is now Asia, existing between 126 and 101 million years ago. It is notable for being the most species-rich dinosaur genus. Up to 12 species are known, from across China, Mongolia, Siberia, and possibly Thailand and Laos. The species of Psittacosaurus were obligate bipeds at adulthood, with a high skull and a robust beak. One individual was found preserved with long filaments on the tail, similar to those of Jianyu long, and scales across the rest of the animal. Psittacosaurus probably had complex behaviors, based on the proportions and relative size of the brain. It may have been active for short periods of time during the day and night, and had well-developed senses of smell and vision. Psittacosaurus was one of the earliest ceratopsians, but closer to Triceratops than Yilong. Once in its own family, Psittacosauridae, with other genera like Hongshannosaurus, it is now considered to be senior synonym of the latter and an early offshoot of the branch that led to more derived forms. The genera closely related to Psittacosaurus are all from Asia, with the exception of Aquilops, from North America. The first species was either Phylogenetic or closely related, and it may have given rise to later forms of Psittacosaurus. Psittacosaurus is one of the most completely known dinosaur genera. Fossils of hundreds of individuals have been collected so far, including many complete skeletons. Most age classes are represented, from hatchling through to adult, which has allowed several detailed studies of Psittacosaurus growth rates and reproductive biology. The abundance of this dinosaur in the fossil record has led to the labeling of Lower Cretaceous sediments of East Asia the Psittacosaurus biochrone. History of discovery. Psittacosaurus was first described as a genus in 1923, by Henry Fairfield Osborn. He named the type species P. mongoliensis, for the location of its discovery in Mongolia, placing it in the new family Psittacosauridae. Remains of this dinosaur were first discovered the year before, on the Third American Museum of Natural History expedition to the Gobi Desert of Mongolia, when one of the expedition's drivers, Wang, found the type specimen, AMNH 6254, which preserves a nearly complete skull, as well as a postcranial skeleton lacking sections of the limbs. This same expedition turned up the remains of many other famous Mongolian dinosaurs, including Protoceratops, Oviraptor, and Velociraptor. Many later expeditions by various combinations of Mongolian, Russian, Chinese, American, Polish, Japanese, and Canadian paleontologists also recovered specimens from throughout Mongolia and northern China. In these areas, Psittacosaurus mongoliensis fossils are found in most sedimentary strata dating to the Aptian to Albian stages of the early Cretaceous period, or approximately 125 to 100 Maya. Fossil remains of over 75 individuals have been recovered, including nearly 20 complete skeletons with skulls. Individuals of all ages are known, from hatchlings less than 13 centimeters, 5.1 in, long, to very old adults reaching nearly 2 meters, 6 feet 7 in length. When describing Psittacosaurus mongoliensis in 1923, Osborn also gave the name Protegonodon mongoliensis to another skeleton found nearby, believing it to represent an ancestor of the ornithopod iguanodon, in the new subfamily Protegonodontinae. Protegonodon mongoliensis, AMNH 6523, measured 1.35 meters, 4 feet 5 in, long, and was known from much of the skeleton, although at the time of description the neck vertebrae were still covered by matrix. Osborn diagnosed his taxa on the basis of features of the teeth and snout. However, modern taxonomists find these features insignificant, instead placing Protegonodon mongoliensis within Psittacosaurus mongoliensis. When the skeleton was prepared further, it became clear that it was nearly identical to Psittacosaurus mongoliensis. In 1958, Chinese paleontologist Yang Zhongzhen, better known as C.C. Young, renamed the skeleton Psittacosaurus protegonodonensis. Today the specimen is generally referred to as the species Psittacosaurus mongoliensis, and the names Protegonodon mongoliensis and Psittacosaurus protegonodonensis are considered junior synonyms of the name Psittacosaurus mongoliensis, which was coined first. In 1931, C. Young named a new species of Psittacosaurus for a partial skull discovered in Inner Mongolia, China. The skull was named P. osborni after Henry Fairfield Osborn. The validity of this species is now considered equivocal. Serino, 1990, considered it a synonym of P. mongoliensis, which is found in nearby strata of the same age. Yu and Dodson, 2004, listed it as valid in a table, but not in their text. In a 2010 review, Serrano again regarded P. osborni as a synonym of P. mongoliensis, but noted it was tentative because of the presence of multiple valid Psittacosaurus species in Inner Mongolia. Young also described the species P. tingi in the same 1931 report which contained P. osborni. It is based on several skull fragments. He later synonymized the two species under the name P. osborni. Yu and Dodson, 2004, followed this in a table, but Serrano regarded both species as synonyms of P. mongoliensis. A table in the latter reported P. tingi as a nomen dubium, however. The front half of a skull from Guyai County in Inner Mongolia was described as Cydicosaurus guyangensis in 1983. Disarticulated postcranial remains representing multiple individuals were found at the same locality and were assigned to the species. While it differs from the type specimen of P. mongoliensis, it falls within the range of individual variation seen in other specimens of that species and is no longer recognized as a valid species. Yu and Dodson, 2004, included P. guyangensis in a table of valid taxa, but did not include it as such in their text. Assigned species. 17 species have been referred to the genus Psittacosaurus, although only 9 to 11 are considered valid today. This is the highest number of valid species currently assigned to any single dinosaur genus, not including birds. In contrast, most other dinosaur genera are monospecific, containing only a single known species. The difference is most likely due to artifacts of the fossilization process. While Cydicosaurus is known from hundreds of fossil specimens, most other dinosaur species are known from far fewer, and many are represented by only a single specimen. With a very high sample size, the diversity of Cydicosaurus can be analyzed more completely than that of most dinosaur genera, resulting in the recognition of more species. Most extant animal genera are represented by multiple species, suggesting that this may have been the case for extinct dinosaur genera as well, although most of these species may not have been preserved. In addition, most dinosaurs are known solely from bones and can only be evaluated from a morphological standpoint, whereas extant species often have very similar skeletal morphology but differ in other ways which would not normally be preserved in the fossil record, such as behavior, or coloration. Therefore, actual species diversity may be much higher than currently recognized in this and other dinosaur genera. As some species are known only from skull material, species of Cydicosaurus are primarily distinguished by features of the skull and teeth. Several species can be recognized by features of the pelvis as well. In the 1950s, a new Chinese species of Cydicosaurus was found in the Apshanalbian Qingshan Formation of Shandong Province, southeast of Beijing. C. Young called it P. sinensis to differentiate it from P. mongoliensis, which had originally been found in Mongolia. Fossils of more than 20 individuals have since been recovered, including several complete skulls and skeletons, making this the most well-known species after P. mongoliensis. Chinese paleontologist Zhao Zijin named a new species after his mentor, C. Young, in 1962. However, the type specimen of P. youngi, a partial skeleton and skull, was discovered in the same rocks as P. sinensis and appears to be very similar, so P. youngi is generally considered a junior synonym of that better-known species. As with P. guyangensis and P. osborni, Yu and Dodson, 2004, listed it as valid in a table, but not in their text. In 1988, Zhao and American paleontologist Paul Serrano described P. xinjiangensis, named after the Xinjiang Autonomous Region in which it was discovered. Several individuals of different ages were discovered in the early 1970s by Chinese paleontologists and described by Serrano and Zhao, although the holotype and most complete skeleton belonged to a juvenile. An adult skeleton was later discovered at a different locality in Xinjiang. These specimens come from the upper part of the Tugulu group, which is regarded as Apshanalbian in age. A second species described in 1988 by Serrano and Zhao, along with two Chinese colleagues, was P. maliensis from the Jufotang Formation, near the town of Mailiangzi, Liaoning Province, northeastern China. This species is known from 4 fossil skulls, one associated with some skeletal material, found in 1973 by Chinese scientists. The age of the Jufotang in Liaoning is unknown, but in the neighboring province of Inner Mongolia, it has been dated to about 110 Ma, in the Albian stage of the early Cretaceous. French paleontologist Eric Buffetot and a Thai colleague, Thorn, described a partial upper and lower jaw from the Apshanalbian Kok Kruot Formation of Thailand in 1992, giving it the name P. satiraki. In 2000, Sereno questioned the validity of this species, citing its eroded and fragmentary nature, and noted an absence of features characteristic of the genus Psittacosaurus. However, in 2002 the original authors published new images of the fossil which seem to show teeth in the lower jaw that exhibit the bulbous vertical ridge characteristic of Psittacosaurus. Other authors have also defended its validity, while some continue to regard it as dubious. Sereno, 2010, proposed that the best assignment for the type material may be Ceratopsia and Certicetus. Two new species of Psittacosaurus were described by Canadian Dale Russell and Zhao in 1996. The first was named P. mongoliensis, after the Mandarin Chinese name for Inner Mongolia. It is based on a nearly complete fossil skeleton, including most of the skull, found in the early Cretaceous Ijinhoro Formation with 7 other individuals. Russell and Zhao also named P. ordosensis in 1996, after the Ordos prefecture of the Inner Mongolia Autonomous Region. The type specimen is a nearly complete skeleton, including part of the skull. However, only the skull, lower jaw, and foot have been described. 3 other specimens were referred to this species but remain undescribed. Like P. mongoliensis, this species was discovered in the Ijinhoro Formation. Sereno, 2010, found the species as described to be indistinguishable from P. sinensis, another small species, but suggested that additional study of P. ordosensis might reveal diagnostic features. He provisionally designated P. ordosensis a nomen dubium. Xu Xing, another Chinese paleontologist, named a new species of Psittacosaurus in 1997, based on a complete skull with associated vertebrae and a forelimb. This material was recovered in Gansu province, near the border with Inner Mongolia. This species is named P. mazongshanensis after the nearby mountain called Mazongshan, Horse Mane Mountain, and has been described in a preliminary manner. Unfortunately, the skull was damaged while in the care of the Chinese Institute of Vertebrate Paleontology and Paleoanthropology, IVPP, and several fragments have been lost, including all of the teeth. The remains were found in the lower Xianmenbao Formation, which have not been precisely dated, although there is some evidence that they were deposited in the late Barremian through Aptian stages. Sereno suggested in 2000 that P. mazongshanensis was a nomen dubium, with no unique features that separated from any other species of Psittacosaurus. However, more recent authors have noted that it can be distinguished by its proportionally long snout compared to other species of Psittacosaurus, as well as a prominent bony protuberance, pointing outwards and downwards, on the maxilla of the upper jaw. The maxillary protuberance is also now missing. Other features originally used to distinguish the species have been recognized as the results of the deformation of the skull after fossilization. Sereno, 2010, remained unconvinced of its validity. Beginning in the 1950s, Russian paleontologists began excavating Psittacosaurus remains at a locality near the village of Shestikovo in the oblast of Kemerovo in Siberia. 2 other nearby localities were explored in the 1990s, one of which produced several complete skeletons. This species was named P. sibiricus in 2000 in a scientific paper written by 5 Russian paleontologists, but credit for the name is officially given to 2 of those authors, Alexei Voronkevich and Alexander Avryanov. The remains were not completely described until 2006. 2 nearly complete, articulated skeletons and a variety of disarticulated material from other individuals of all ages are known from the Alek Formation of Siberia, which ranges from the Aptian to Albian stages of the early Cretaceous. Phylogenetic, named in 2006 by Chinese paleontologist Zhou Chongfu and 3 Chinese colleagues, is one of the oldest known species, based on 4 skulls from the lower beds of Yixian Formation, near the village of Lujiachun. While this bed has been dated differently by different authors, from 128 Ma in the Barremian stage, to 125 Ma in the earliest Aptian, revised dating methods have shown them to be about 123 million years old. Phylogenetic was contemporaneous with another psittacosaurid species, Hongshanosaurus howi, which was found in the same beds. It is potentially synonymous with H. howi. Sereno, 2010, who proposed that Hongshanosaurus is a synonym of Psittacosaurus, opted to leave P. Lugiatunensis and H. howi separate species due to the inadequacies of the latter's type specimen. One nearly complete skeleton of P. lugiatunensis from the same lower beds of the Yixian Formation had previously been classified in its own species, Psittacosaurus major, named for the large size of its skull by Sereno, Zhao and 2 colleagues in 2007. Yu and colleagues described an additional specimen and concurred that it was distinct from P. lugiatunensis. P. major was originally characterized by a proportionally large skull, which was 39% of the length of its torso, compared to 30% in P. mongoliensis, and other features. However, a 2013 study utilizing morphometric analysis showed that the supposed differences between P. lugiatunensis and P. major were due to differences in preservation and crushing. The study concluded that both represented a single species. A third species of Lugiachun Psittacosaur, the first to be named, was described as Hongshannosaurus howi in 2003. The generic name Hongshannosaurus was derived from the Mandarin Chinese words, Hong, red, and Shan, hill, as well as the Greek word sauros, lizard. This name refers to the ancient Huangshan culture of northeastern China, who lived in the same general area in which the fossil skull of Hongshannosaurus was found. The type and only named species, H. howi, honors Halianhai, a professor at the IVPP in Beijing, who curated the specimen. Genus and species were both named by Chinese paleontologists Yu Hailu, Xu Xing, and Wang Shaolin in 2003. Sereno, 2010, regarded its distinct proportions as due to crushing and compression of the Hongshannosaurus skulls. He regarded Hongshannosaurus as a junior synonym of Cydicosaurus, and potentially the same as P. lugiatunensis. He did not synonymize the two species because of difficulties with the holotype skull of H. howi, instead considering new combination P. howi a nomen dubium within Psittacosaurus. Sereno's hypothesis was supported by a morphometric study in 2013, which found P. howi and P. lugiatunensis to be synonymous. While P. howi is the oldest available name, the researchers argued that because the type specimen of P. lugiatunensis was better preserved, the correct name for this species should be P. lugiatunensis rather than P. howi, which would normally have priority. P. gobiensis is named for the region it was found in 2001, and first described by Sereno, Zhao and Lin in 2010. It is known from a skull and partial articulated skeleton with gastroliths. Many other specimens either cannot be determined to belong to any particular species, or have not yet been assigned to one. These specimens are generally all referred to as Cydicosaurus sp, although it is not assumed that they belong to the same species. More than 200 specimens of Psittacosaurus have been found in the Yixian Formation, which is famous for its fossils of feathered dinosaurs. The vast majority of these have not been assigned to any published species, although many are very well preserved and some have already been partially described. Nearly 100 Psittacosaurus skeletons were excavated in Mongolia during the summers of 2005 and 2006 by a team led by Mongolian paleontologist Bulortsetseg and American Jack Horner from the Museum of the Rockies in Montana. Although only P. mongoliensis has been described from Mongolia so far, these specimens are still in preparation and have not yet been assigned to a species. Description: the species of Psittacosaurus vary in size and specific features of the skull and skeleton, but share the same overall body shape. The best known, P. mongoliensis, can reach 2 meters (6.5 feet) in length. The maximum adult body weight was most likely over 20 kilograms (44 pounds) in P. mongoliensis. Several species approach P. mongoliensis in size: P. lugiatunensis, P. mongoliensis, P. xinjiangensis, while others are somewhat smaller: P. sinensis, P. maliensis. The smallest known species, P. ordosensis, is 30% smaller than P. mongoliensis. The largest are P. lugiatunensis and P. sibiricus, although neither is significantly larger than P. mongoliensis. Psittacosaurus postcranial skeletons are more typical of a generic bipedal ornithischian. There are only 4 digits on the manus, hand, as opposed to the 5 found in most other ornithischians, including all other ceratopsians, while the 4-toed hindfoot is very similar to many other small ornithischians. The skull of Psittacosaurus is highly modified compared to other ornithischian dinosaurs of its time. Extremely tall in height and short in length, the skull has an almost round profile in some species. The portion in front of the orbit, eye socket, is only 40% of total skull length, shorter than any other known ornithischian. The lower jaws of Psittacosaurs are characterized by a bulbous vertical ridge down the center of each tooth. Both upper and lower jaws sport a pronounced beak, formed from the rostral and predentary bones, respectively. The bony core of the beak may have been sheathed in keratin to provide a sharp cutting surface for cropping plant material. As the generic name suggests, the short skull and beak superficially resemble those of modern parrots. Psittacosaurus skulls share several adaptations with more derived ceratopsians, such as the unique rostral bone at the tip of the upper jaw, and the flared ugal, cheek, bones. There is still no sign of the bony neck frill or prominent facial horns which would develop in later ceratopsians. Bony horns protrude from the skull of P. sibiricus, but these are thought to be an example of convergent evolution. Soft tissue and coloration. The integument, or body covering, of Psittacosaurus is known from a Chinese specimen, which most likely comes from the Yixian Formation of Liaoning Province, China. The specimen, which is not yet assigned to any particular species, was likely illegally exported from China and was donated to the Singenberg Museum in Germany. It was described while awaiting repatriation. Previous repatriation attempts were unsuccessful. Most of the body was covered in scales. Larger scales were arranged in irregular patterns, with numerous smaller scales occupying the spaces between them, similarly to skin impressions known from other ceratopsians, such as Chasmosaurus. A series of what appear to be hollow, tubular bristle-like structures, approximately 16 centimeters, 6.3 in, long, were also preserved, arranged in a row down the dorsal, upper, surface of the tail. These were confirmed by the authors, as well as an independent scientist, to not represent plant material. The bristle-like integumentary structures extend into the skin nearly to the vertebrae, and were likely circular or tubular before being preserved. Under ultraviolet light, they gave off the same fluorescence as scales, providing the possibility they were keratinized. The study stated that, at present, there is no convincing evidence which shows these structures to be homologous to the structurally different integumentary filaments of theropod dinosaurs. However, they found that all other feather-like integument from the Yixian Formation could be identified as feathers. In 2008, another study was published describing the integument and dermis of Psittacosaurus sp. from a different specimen. The skin remains could be observed by a natural cross-section to compare them to modern animals, showing that dinosaurian dermal layers evolved in parallel to those in many other large vertebrates. The collagen tissue fibers in Psittacosaurus are complex, virtually identical to all other vertebrates in structure but having an exceptional thickness of about 40 layers. As the sections of dermis were collected from the abdomen, where the scales were eroded, the tissue may have assisted with the musculature of the stomach and intestines and offered protection against predators. As described in a 2016 study, examination of melanosomes preserved in the specimen of Psittacosaurus preserved with integument indicated that the animal was countershaded, likely related to living in a dense forest habitat with little light. Much like many modern species of forest-dwelling deer and antelope, stripes and spots on the limbs may represent disruptive coloration. The specimen also had dense clusters of pigment on its shoulders, face, possibly for display, and cloaca, which may have had an antimicrobial function, as well as large patagia on its hind legs that connected to the base of the tail. Its large eyes indicate that it also likely had good vision, which would have been useful in finding food or avoiding predators. The authors pointed out that there might have been variation in coloration across the range of the animal, depending on differences in the light environment. The authors were unable to determine which species of Jahal Formation Psittacosaurus the specimen belonged to due to the way the skull is preserved, but ruled out P. mongoliensis, based on hip features. Another 2016 study used laser-stimulated fluorescence imaging to analyze the internal structure of the bristles. The highly cornified bristles were arranged in tight clusters of 3 to 6 individual bristles, with each bristle being filled with pulp. The authors considered the bristles as being most similar to the quills of Dianu long, and the sparsely distributed elongated broad filamentous feathers, EBFFs, of Paleosaurus. Similar, non-feather-derived bristles are found in a few extant birds such as the horn on the horned screamer and the beards of turkeys. These structures differ from feathers in that they are unbranched, heavily cornified and do not develop from a follicle, but instead arise from discrete cell populations that exhibit continuous growth. A darkened soft tissue structure was also found near the ugal horn. This may represent a keratinous sheath or skin flap. A 2020 study of SMFR 4970 identified it as an approximately 6 to 7 year old subadult, and found it preserves the first cloaca known from a non-Avalian dinosaur. The positioning of the individual when it died means that both sides of the structure can be seen, although the right side is better preserved. Cydicosaurus cloaca is comparable to those of crocodilians, with a longitudinally opening vent and a rosette pattern of cloacal scales and 129 transverse rows of quadrangular ventral scale, as opposed to the naked area around the cloaca of birds. Like modern crocodilians and birds, dinosaur genitalia were positioned internally. Since SMFR 4970 was not fully sexually mature when it died, unfortunately the fully matured structure, as well as the sex of the individual and any coecophallus that may have been present in life, are undetermined. Species characteristics. Skulls of P. mongoliensis are flat on top, especially over the back of the skull, with a triangular depression, the antorbital fossa, on the outside surface of the maxilla, an upper jaw bone. A flange is present on the lower edge of the dentary, the tooth-bearing bone of the lower jaw, although it is not as prominent as in P. maliensis or P. major, equals P. lugiatunensis. P. mongoliensis is among the largest known species. The skull of the type specimen, which is probably a juvenile, is 15.2 centimeters, 6 in, long, and the associated femur is 16.2 centimeters, 6.4 in length. Other specimens are larger, with the largest documented femur measuring about 21 centimeters, 8.25 in, long. P. sinensis is readily distinguished from all other species by numerous features of the skull. Adult skulls are smaller than those of P. mongoliensis and have less teeth. Uniquely, the premaxillary bone contacts the ugal, cheek, bone on the outside of the skull. The juggles flare out sideways, forming horns proportionally wider than in any other known Psittacosaurus species except P. sibiricus and P. lugiatunensis. Because of the flared cheeks, the skull is actually wider than it is long. A smaller horn is present behind the eye, at the contact of the ugal and postorbital bones, a feature also seen in P. sibiricus. The mandible, lower jaw, lacks the hollow opening, or fenestra, seen in other species, and the entire lower jaw is bowed outwards, giving the animal the appearance of an underbite. The skull of an adult P. sinensis can reach 11.5 centimeters, 4.5 in length. P. sibiricus is the largest known species of Psittacosaurus. The skull of the type specimen is 20.7 centimeters long, 8.25 in, and the femur is 22.3 centimeters, 8.75 in length. It is also distinguished by its neck frill, which is longer than any other species, at 15 to 18% of skull length. A very striking feature of P. sibiricus is the number of horns around the eyes, with 3 prominences on each postorbital, and 1 in front of each eye, on the palpebral bones. Similar horns found on the postorbital of P. sinensis are not as pronounced but may be homologous. The ugal has extremely prominent horns and may contact the premaxilla, both features also seen in the possibly related P. sinensis. There is a flange on the dentary of the lower jaw, similar to P. mongoliensis, P. maliensis, and P. satyraki. It can be told apart from the other species of Psittacosaurus by a combination of 32 anatomical features, including 6 that are unique to the species. Most of these are skull details, but one unusual feature is the presence of 23 vertebrae between the skull and pelvis, unlike the 21 or 22 in the other species where the vertebrae are known. P. xiangensis is distinguished by a prominent ugal horn that is flattened on the front end, as well as some features of the teeth. The ilium, one of the 3 bones of the pelvis, also bears a characteristically long bony process behind the acetabulum, hip socket. An adult femur has a published length of about 16 centimeters, 6.3 in. P. maliensis has the shortest snout and neck frill of any species, making the skull nearly circular in profile. The orbit, eye socket, is roughly triangular, and there is a prominent flange on the lower edge of the dentary, a feature also seen in specimens of P. lugiatunensis, and to a lesser degree in P. mongoliensis, P. satyraki, and P. sibiricus. The complete type skull, probably adult, is 13.7 centimeters, 5.5 in, long. The dentary of P. satyraki has a flange similar to that found in P. mongoliensis, P. sibiricus, P. lugiatunensis and P. maliensis, although it is less pronounced than in those species. The material appears to be roughly the same size as P. sinensis. The frontal bone of P. mongoliensis is distinctly narrow compared to that of other species, resulting in a narrower skull overall. The ischium bone of the pelvis is also longer than the femur, which differs from other species in which these bones are known. The type specimen has a skull length of 13.2 centimeters, 5.2 in, and a femoral length of 13 centimeters, 5.1 in, but is not fully grown. An adult P. mongoliensis was probably smaller than P. mongoliensis, with a proportionally longer skull and tail. P. ordosensis can be distinguished by numerous features of the juggles, which have very prominent horns. It is also the smallest known species. One adult skull measures only 9.5 centimeters, 3.75 in length. The type skull of P. lugiatunensis measures 19 centimeters, 7.5 in length, while the largest known skull is 20.5 centimeters, 8 in long, so this species was similar in size to P. mongoliensis and P. sibiricus. There is a fossa in front of the eye, as in P. mongoliensis. The ugal bones flare outwards widely, making the skull wider than it is long, as seen in P. sinensis. Widely flared juggles are also found in P. sibiricus. Overall, This species is thought to exhibit several primitive characteristics compared to other species of Psittacosaurus, which is consistent with its greater geological age. P. gobiensis was small-bodied, 1 meter, 3 feet 3 in, long, and differs from other species of Psittacosaurus by significant, but structurally minor, details. These include the presence of a pyramidal horn on the postorbital, a depression on the postorbital eugal contact, and enamel thickness. P. mongoliensis was a contemporary. Classification. Psittacosaurus is the type genus of the family Psittacosauridae, which was also named by Osborn in 1923. Psittacosaurids were basal to almost all known ceratopsians except Jianlong and perhaps the Kiaiyangsauridae. While Psittacosauridae was an early branch of the ceratopsian family tree, Psittacosaurus itself was probably not directly ancestral to any other groups of ceratopsians. All other ceratopsians retained the fifth digit of the hand, a plesiomorphy or primitive trait, whereas all species of Psittacosaurus had only 4 digits on the hand. In addition, the antorbital fenestra, an opening in the skull between the eye socket and nostril, was lost during the evolution of Psittacosauridae, but is still found in most other ceratopsians and in fact most other archosaurs. It is considered highly unlikely that the fifth digit or antorbital fenestra would evolve a second time. In 2014, the describers of a new taxon of basal ceratopsian published a phylogenetic analysis encompassing Psittacosaurus. The below cladogram is from their analysis, placing the genus as one of the most primitive ceratopsians. The authors, Farkai et al., noted that all taxa outside of Leptoceratopsidae and Coronosauria with the exception of their genus Aquilops are from Asia, meaning the group likely originated there. Although many species of Psittacosaurus have been named, their relationships to each other have not yet been fully explored and no scientific consensus exists on the subject. Several phylogenetic analyses have been published, with the most detailed being those by Alexander Avrianov and colleagues in 2006, Hailu Yu and colleagues in 2008, and Paul Sereno in 2010. The middle one is shown below. In 2005, Zhou and colleagues suggested that Paleobiology is basal to all other species. This would be consistent with its earlier appearance in the fossil record. Paleobiology. The brain of P. lugiatunensis is well known. A study on the anatomy and functionality of 3 specimens was published in 2007. Until the study, it was generally thought the brain of Psittacosaurus would have been similar to other ceratopsians with low encephalization quotients. Russell and Zhao, 1996, believe the small brain size of Psittacosaurus implies a very restrictive behavioral repertoire relative to that of modern mammals of similar body size. However, the 2007 study dispelled this theory when it found the brain to be more advanced. There is generally negative allometry for brain size with development in vertebrates, but this was shown not to be true in Psittacosaurus. The EQ score for P. lugiatunensis is 0.31, significantly higher than genera such as Triceratops. A higher EQ correlates with more complex behavior, and various dinosaurs have high EQs, similar to birds, which range from 0.36 to 2.98. Thus, Psittacosaurus behavior could have been as complex as that in Tyrannosaurus, whose EQ ranges from 0.30 to 0.38. Behaviors influenced by high EQs include nest building, parental care, and bird-like sleeping, some of which have been shown to be present in Psittacosaurus. The senses of Psittacosaurus can be inferred from the endocast. Large olfactory bulbs are present, indicating the genus had an acute sense of smell. The size of these bulbs are comparable to large predatory theropods, although they likely evolved to avoid predators instead of to seek out prey. The sclerotic rings in reptiles directly show the size of the eyeball. The rings are not well preserved in Psittacosaurus, with one individual preserving them likely contracted post-mortem, but if they are similar to those of Protoceratops, Psittacosaurus would have had large eyes and acute vision. The curvature of the semicircular canals is related to the agility of reptiles, and the large curved canals in Psittacosaurus show that the genus was much more agile than later ceratopsians. Comparisons between the scleral rings of Psittacosaurus and modern birds and reptiles suggest that it may have been cathemeral, active throughout the day and for short intervals at night. Ford and Martin, 2010, proposed that Psittacosaurus was semi-aquatic, swimming with its tail like a crocodile, and paddling and kicking. They based their interpretation on evidence including the lacustrine, lake, depositional setting of many specimens, the position of the nostrils and eyes, interpretations of the motions of the arms and legs, tails with long chevrons, and with the bristles on the tail interpreted as possibly skin-covered, forming a fin, providing a propulsive surface, and the presence of gastroliths, interpreted as ballast. They further suggested that some species of Psittacosaurus were more terrestrial than others. Diet. Psittacosaurs had self-sharpening teeth that would have been useful for cropping and slicing tough plant material. Unlike later ceratopsians, they did not have teeth suitable for grinding or chewing their food. Instead, they used gastroliths, stones swallowed to wear down food as it passed through the digestive system. Sometimes numbering more than 50, these stones are occasionally found in the abdominal cavities of Psittacosaurs, and may have been stored in a gizzard, as in modern birds. Unlike many other dinosaurs, Psittacosaurs had akinetic skulls, that is to say, the upper and lower jaws each behaved as a single unit, without internal joints. The only joint was the jaw joint itself, and Psittacosaurs could slide their lower jaws forward and backward on the joint, permitting a shearing action. Unlike most ceratopsians, their beaks did not form curved tips, but were instead rounded and flattened. If the jaws were aligned, the beaks could be used to crop objects, but if the lower jaw was retracted so that the lower beak was inside the upper beak, the jaws may have served a nut-cracking function. A nut or seed-rich diet would also match well with the gastroliths often seen in well-preserved Psittacosaur skeletons. Limb function. Studies by Phil Center in 2007 conducted on P. mongoliensis and P. mongoliensis concluded that the forelimbs of these taxa, and likely those of other Psittacosaurus species, were too short, only about 58% as long as the hindlimbs, to reach the ground, and their range of motion indicates they could neither be pronated nor generate propulsive force for locomotion, suggesting that Psittacosaurus was entirely bipedal. The forelimbs were also too short to be used in digging or bringing food to the mouth, and Center suggested that if Psittacosaurus needed to dig depressions in the ground it may have used its hindlimbs instead. The forelimbs could be used for two-handed grasping of objects or scratching the body, but due to their extremely limited flexibility and reach, they could have only been used to grasp objects very close to the belly or sides of the animal and could have scratched only the belly, flank and knees. Even though the hands could not reach the mouth, Psittacosaurus could have still used them to carry nesting material or food to a desired location. However, Psittacosaurus may not have been entirely bipedal for its entire lifespan. Taking sections from the limb bones of 16 specimens of Psittacosaurus, ranging in age from less than a year-old to 10-year-old adults, Chi Zhao from the University of Bristol found that Psittacosaurus was probably secondarily bipedal. The infant's front limbs grew at faster rates than the hind limbs at between birth and 3 years of age. At the age of between 4 and 6 years, arm growth slowed and leg growth accelerated as the animal became mature. At this stage, Psittacosaurus would switch to a bipedal stance. These findings further reveal that the ancestor of Psittacosaurus was likely quadrupedal and eventually gained the ability to become bipedal as it evolved, with the young retaining the quadrupedal gait of the ancestor in question. These findings also lead to the hypothesis that many such dinosaur families may have evolved along this path at some point in their evolution. Growth rate. Several juvenile Psittacosaurus have been found. The smallest is a P. mongoliensis hatchling conserved in the American Museum of Natural History, AMNH, which is only 11 to 13 centimeters, 4 to 5 inches, long, with a skull 2.4 centimeters, 0.94 in length. Another hatchling skull at the AMNH is only 4.6 centimeters, 1.8 in, long. Both specimens are from Mongolia. Juveniles discovered in the Yixian Formation are approximately the same age as the larger AMNH specimen. A histological examination of P. mongoliensis has determined the growth rate of these animals. The smallest specimens in the study were estimated at 3 years old and less than 1 kilogram, 2.2 pounds, while the largest were 9 years old and weighed almost 20 kilograms, 44 pounds. This indicates relatively rapid growth compared to most reptiles and marsupial mammals, but slower than modern birds and placental mammals. An age determination study performed on the fossilized remains of P. mongoliensis by using growth ring counts suggests that the longevity of the basal ceratopsian was 10 to 11 years. Gregarious juveniles. The find of a herd of 6 Psittacosaurus individuals killed and buried by a volcanic mudflow indicates the presence of at least 2 age groups from 2 distinct clutches gathered together. This find has been taken as evidence for group fidelity and gregariousness extending beyond the nest, the earliest such evidence for any ceratopsian. Even very young Psittacosaur teeth appear worn, indicating they chewed their own food and may have been precocial. Another juvenile lonely cluster shows that specimens of different ages group together. These juveniles may have associated together as a close-knit, mixed-age herd either for protection, to enhance their foraging, or as putative helpers at the parental nest. There is no evidence for parental care. In 2004, a specimen found in the Yixian Formation was claimed as evidence for parental care in dinosaurs. The specimen DNHM-D2156 consists of 34 articulated juvenile Psittacosaurus skeletons, closely associated with the skull of an adult. The juveniles, all approximately the same age, are intertwined in a group underneath the adult, although all 34 skulls are positioned above the massive bodies, as they would have been in life. This suggests that the animals were alive at the time of burial, which must have been extremely rapid, perhaps due to the collapse of a burrow. However, a 2013 paper pointed out that the adult specimen did not belong with the nest, its skull having no sedimentary connection to the main slab where the juveniles occurred, but had been glued onto it. This artificial association led to the inference that the skull belonged to an individual, possibly a mother, that was providing parental care for the 34 juveniles, a claim that is unfounded. Furthermore, the adult was also shown to be 6 years old, whereas histological studies have shown P. mongoliensis was unable to breed until it reached 10 years of age. It is also unlikely that a single female would have so many offspring at one time. A 2014 analysis of the same specimen supported the association and concluded that the proximity of the 6-year-old specimen to the post-hatchlings may indicate post-hatchling cooperation, making the 6-year-old specimen a possible caretaker. Pathology. Out of the hundreds of known Cydicosaurus specimens, only one has been described to possess any sort of pathology. The specimen in question, consisting of a complete adult skeleton and tentatively assigned to P. mongoliensis, was found in the lower beds of the Yixian Formation. There is no sign of a bone fracture, but very clear signs of an infection can be seen near the midpoint of the right fibula. The bone exhibits a large round pit, evidence of necrosis due to a lack of blood supply to the region. The pit is surrounded by a massive amount of swelling along the lower third of the bone. This large amount of bone deposited around the injury indicates that the animal survived for quite a while despite the injury and subsequent infection. As Psittacosaurids were bipedal animals, a similar injury to a weight-bearing bone in the leg would most likely have been fatal. Unlike the femur and tibia, the fibula is not a weight-bearing bone, so this animal would still have been able to walk to some extent. The source of the injury remains unknown. Predation. Another fossil from the Yixian Formation provides direct evidence of Psittacosaurus as a prey animal. One skeleton of Rhipenamamus robustus, a large triconodont mammal, is preserved with the remains of a juvenile Psittacosaurus in its abdominal cavity. Several of the juvenile's bones are still articulated, indicating that the carnivorous mammal swallowed its prey in large chunks. This specimen is notable in that it is the first known example of Mesozoic mammals preying on live dinosaurs. Heavy predation on juvenile Psittacosaurus may have resulted in our selection, the production of more numerous offspring to counteract this loss. Paleochronology. Psittacosaurus is known from hundreds of individual specimens, of which over 75 have been assigned to the type species, P. mongoliensis. All Psittacosaurus fossils discovered so far have been found in early Cretaceous sediments in Asia, from southern Siberia to northern China, and possibly as far south as Thailand. The most common age of geologic formations bearing Psittacosaurus fossils is from the late Barremian through Albian stages of the early Cretaceous, or approximately 126 to 101 million years ago. Many terrestrial sedimentary formations of this age in Mongolia and northern China have produced fossils of Psittacosaurus, leading to the definition of this time period in the region as the Psittacosaurus biochron. The earliest known species is Phylogenetic, found in the lowest beds of the Yixian Formation. Over 200 specimens attributed to this genus have been recovered from these and other beds of the Yixian, the age of which is the subject of much debate. Although many early studies using radiometric dating put the Yixian in the Jurassic period, tens of millions of years outside of the expected temporal range of Psittacosaurus, most recent work dates it to the early Cretaceous. Using Argon dating, a team of Chinese scientists dated the lowest beds in the formation to about 128 and the highest to approximately 122 A more recent Chinese study, using uranium lead dating, suggests that the lower beds are younger, approximately 123.2 while agreeing with an age of 122 for the upper beds.